Hello dear students, today the topic of the class is wrapping effect. The topic is from the bilinear transformation method, IIR filter, digital filter. In the last class we have seen the bilinear transformation method. We have derived what is the relation between analog and digital frequencies in using bilinear transformation method. Okay, so what is the advantage of bilinear transformation method? It's a one-to-one mapping, conformal mapping. The bilinear transformation method is a conformal mapping which transforms the j-ohm axis into the unit circle in the z-plane only once. Okay, this is the one-to-one mapping. This is advantage of bilinear transformation. In impulse invariant technique, it's a many to one mapping which causes aliasing. So, aliasing was the drawback of impulse invariant technique. So, bilinear transformation method is having the advantage of one to one mapping. Coming to the disadvantage of bilinear transformation method, it's a frequency wrapping. The drawback is known as the wrapping effect. Okay. So, let us see what is wrapping effect. Is a drawback of bilinear transformation method, and what is the effect of wrapping effect on amplitude response and phase response of a digital filter. So, let us start the wrapping effect. We have derived the equation ohm is equal to 2 by T tan omega by 2. Ohm is the analog frequency, omega is the digital frequency. This equation we have derived in the previous video class. If this value is small, if omega value is small, what happens for a small value of theta? Tan theta is approximated to theta. So, we can write here this one, if omega is small, so we can write this tan omega by 2 as omega by 2. Okay, so this 2 gets cancelled. So, we are getting ohm is equal to omega by t, or we can write omega is equal to ohm t. For small values of omega is giving to a linear relationship. Okay. So, for low frequencies the relationship between ohm and omega are linear. As a result, the digital filter has the same amplitude response as the analog filter. Okay, so at low frequencies, the relation between ohm, that is analog frequency, and digital frequency is linear. But at high frequency, what is happening? It's coming to be non-linear because of this equation 2 by T tan omega by 2, that is due to this tan term, which is also known as arctangent function. So, let us go into the amplitude and phase response leading to distortion due to wrapping effect. So, we have seen the relationship between omega and ohm becomes non-linear and the distortion is increased in the frequency scale of the digital filter due to the equation 2 by T tan omega by 2. This equation is responsible for wrapping effect. Okay, what is happening in wrapping effect? The amplitude and phase responses get distorted at high frequencies, but at low frequency omega and ohm are having the linear relationships. So, there is no distortion at low frequencies, but coming to high frequency the responses are getting distorted, which is known as wrapping effect. So, let us see the magnitude response. Okay. So, this is a graph between ohm t, that is analog frequency, and digital frequency omega. How it is? 2 by T tan omega by 2. So, for that the graph is coming to be of this kind. Okay. Now this is a non-linear graph. Now we are considering an magnitude response of an analog filter, which is symbolized by mod of h of j ohm versus ohm. Consider an analog filter containing pass bands centered at uniform frequencies. Okay, considering an analog filter with number of pass bands centered at regular intervals. Okay, now when they are coming to this is analog filter magnitude response. Now what will be the effect of this magnitude response of this analog filter on digital filter magnitude response? The magnitude filter transfer function is denoted as mod of h of e to the power of j omega versus omega. Okay. So how it is going to be mapped? So if you carefully see this pass band, the first pass band is going to be plotted like this in the digital domain. Okay, and the second pass band is now plotted like this, and the third pass band correspondingly plotted like this. Okay, so what we are observing, the pass band width is disproportionately changing. That means the center frequency is also changing. Here this is a analog filter magnitude response and this is a digital filter magnitude response. So here the analog filter is having number of pass bands centered at regular intervals, whereas it will have this digital filter will have same number of pass bands. Here 3 pass bands, here also 3 pass bands are there, but the pass band will tend to reduce, the width is going reduced. So this is known as wrapping effect of on magnitude response. Okay, so why this is coming? This is analog filter magnitude response and this is digital filter magnitude response. So number of pass bands are same, but the widths are changing disproportionately. The effect, this is known as the effect on magnitude response due to wrapping effect. So this effect is due to wrapping. What is the equation responsible for giving to non-linearity is ohm is equal to 2 by t tan of omega by 2. That is arc tangent function is responsible for this disproportionate pass bands. So this is the effect of magnitude response on due to wrapping effect. So what is in terms of words, how can we express it? The influence of wrapping effect on amplitude response. We can say amplitude response or magnitude response, both the words are synonymous here. By considering an analog filter with number of pass bands centered at regular intervals, but the derived digital filter will have same number of pass bands and tend to reduce disproportionately. Okay, so the wrapping effect is due to this equation, omega is equal to 2 by t tan omega by 2. Now coming to the phase response, what is the effect of wrapping effect on phase response? So let us see the phase response graph. So again we have to draw the graph for relation graph between ohm t and omega. Okay. So, this is a non-linear graph we are getting like this. Now, let me draw, we have already drawn it here. This is a phase response of analog filter. The phase response is denoted by angle h of j ohm versus ohm. This is the phase response. Let us take, this is a linear phase response for an analog filter. This is a phase response of, how the phase response is, linear phase response we are taking here, linear phase response of analog filter. When we are giving this linear analog phase response of an analog filter to a bilinear transformation method, how the graph is resulting? So, we have to see what is the phase response of the digital filter. So, angle of h of e to the power of j ohm versus omega. This is a phase response. If you give the linear phase, how the phase response is coming? It is coming to be curved like this. So, when the linear phase response of an analog filter is given to a bilinear transformation, it is coming to be non-linear phase response. So, this is the known as the effect of, this graph is known as effect of phase response due to wrapping effect. So, what we have done here, considering an analog filter with linear phase response, the phase response of the derived digital filter will be non-linear. So, from this we lead to two very important conclusions of wrapping effect. Wrapping effect is the disadvantage of bilinear transformation technique, and it is resulting due to the equation ohm is equal to 2 by t tan omega by 2. So, this effect, wrapping effect, is seen in both magnitude response and phase response. When disproportionate pass bands in derived one, and when we are giving a linear phase response, the derived digital filter will be giving the non-linear phase response. So, wrapping effect is the disadvantage. So, in the next class we will see how to avoid this wrapping effect. Okay. So, bilinear transformation method is used for the design of IIR filter. By second point, bilinear transformation method is an indirect method of designing an IIR filter. First, we have to find the transfer function of an analog filter and then transform it to digital filter by using the relation S is equal to 2 by T 1 minus Z inverse by 1 plus Z inverse. So, by seeing the equation ohm is equal to 2 by T tan omega by 2, the effect of magnitude and phase response is not similar as that of analog filter due to wrapping effect. It is leading to certain distortions at higher frequencies. This wrapping effect can be avoided by pre-wrapping the frequencies, which we will be seeing in the next class. I hope you have understood the class. If you have any queries, post in the comment section. Thank you. Good luck, students.